Hey, integrated one. Just making a video for you guys today for class so that if you want to, you can go to Canvas, go back over this, and go through how to solve systems of equations a few times if you didn't get it the first time. So here we go. This is your walkabout problem right here. And after a minute, what we're going to do is solve. Now it says we're needing to solve for y, and we need to graph this. So let's go ahead and do that. The things that we need to do in order to solve for y are right over here. We're going to solve and get y by itself, which means we need to get rid of all the things around y. So I'm going to start with the things that are furthest away. Get rid of that 3x. We do it to one side, means we have to do it on the other side also. We're going to be left with negative 2y is equal to negative 3x plus 12. We need to now get rid of the thing that's keeping y from being by itself. Y right here, we need to get rid of that negative 2. And so the opposite of times negative 2 is going to be divide by negative 2. And so we do that on all the terms that we have in the equation. We're now going to be left with y is equal to positive 3 over 2x plus 6. Now, the second part of this is asking us to graph it. Now, when we graph something like this, we know that this is a linear function because it comes in that y equals mx plus b form. We know a couple things about it right here. This is going to be our slope, and this is going to be our y-intercept. And our y-intercept is usually where we start the whole thing. Y-intercept being up at 6 is right here. We know it's going to cross that y-axis up there. And the slope is a positive slope, so that means it goes up from left to right. It's going to go up 3 and over 2. Up 3 and over 2. Down 3, back 2. Down 3, back 2. We're now going to connect the points for this right here. And that's going to be the equation for our line, or that's going to be the line for that equation. So today we're going to utilize both of those skills as we get more into solving systems of equations by substitution. And when I solve systems of equations by substitution, I want to highlight what substitution really is. We're substituting one thing for another because those two things are equal. Now, I like to make scones on the weekends. I got a killer scone recipe. It's vegan if you want it to be vegan. I'll share it with you guys on campus or on Canvas someday. So my scone recipe calls for a bunch of dry ingredients, including flour, sugar, baking powder, and salt. And it comes for 2 cups, depending on how big you want. You can scale this up, but 2 cups of flour. And then for sugar, because I scaled it up, I was looking at 15 teaspoons of sugar and 9 teaspoons of baking powder. Now that's a lot of teaspoons to move over. It calls for 1 teaspoon, actually 1/2 teaspoon of salt. And so when we looked at that and we said, okay, well, 15 times to take a scoop and throw it over into the bowl, that seems like a lot. And so we realized that there's something that is equal to a teaspoon. And for every teaspoon, or for every really 3 teaspoons, it's going to be equal to 1 tablespoon. We can convert this into 5 sets of 3 teaspoons, or look at it as 5 tablespoons. All right, 5 tablespoons is a lot easier to measure than 15 teaspoons. Same thing with our baking powder. It turns out to be 3 tablespoons of baking powder. Now, the thing I want to highlight for you is the fact that we plugged in for another one thing for another that was equivalent. we know that for every 3 teaspoons is going to be equal to a tablespoon. So we put that in its place. 1 tablespoon in the place of 3 teaspoons. Now this is a little bit of a stretch of a problem to help you guys figure that out. But if I can get my pen to work here, there we go. We're going to take a look at a problem that uses that same kind of idea in substitution. What we have is one thing that is equal to another thing. In this case, we have that y is equal to x plus 8. Y is going to be equal to x plus 8. And because y is equal to x plus 8, I can take that x plus 8 and put it in the place of y for the other equation. Now, when we see our system of equations, a lot of the time they'll be written over top of each other. Sometimes they'll be written next to each other. And I tend to think that this is an easier way to look at it because I can plug it right in just like that. When I do that, instead of having y equals 3 over 2x minus 2, I'm now going to replace that y with x plus 8. And it's going to be equal to negative 3 over 2x minus 2. And so we have a problem that now only has one variable. And we know if something has one variable, we can solve it and get a number answer. So when I do that, I'm going to multiply everything by 2 because that's going to get rid of my fraction on both sides. There's really only a fraction on the right, but that's going to get rid of it. When we multiply, we end up with 2x plus 16 is equal to, the 2 cancels out here, negative 3x minus 4. And so we're going to add 3x to both sides and keep going with this as 5x plus 16 is equal to negative 4. Subtract the 16 from both sides. And you notice how I don't actually show that subtraction. As long as I'm doing the correct process to get to the next step, this is really showing work to get to the next step. You don't have to show what you did. You just have to do it to both sides, and you're good to go. All right, our last step right here, if I can get my pen to work, is going to be dividing by 5 on both sides, and that gives us negative 4. So x is equal to negative 4. That's not the only problem that we need an answer to, because we need to solve for y. And so I'm going to plug it back in because I know x is equal to negative 4. I can plug it back in or substitute back in for the x, negative 4, and I can solve and get that y is equal to a positive 4. So my answer actually comes in the form of a point. It has an x value and a y value, and that's going to be negative 4, comma 4. This is my answer. And that's how we solve a problem by substitution. We plug in, after we've solved for one variable, we plug it into the other equation. Now, let's look at that same solution and see what it really means right here. Well, the solution that we just had was negative 4, 4. And that point is right here. And we want to highlight that idea because the point is very important to us. The point is going to be where these two lines intersect. So we can actually solve this problem by graphing. I have my first graph, which is the red one up there. It starts at 8. It has a slope of up 1 over 1, up 1 over 1. It also goes the opposite way, down 1, back 1, down 1, back 1. And so we get this going down right there. That's one of my lines. The other line right here is in blue, starts at negative 2, and it goes down 3 over 2, up 3, back 2, up 3, back 2, up 3, back 2. And this is going to be my other line. All right. And so when we see those two, they intersect right there at the point -4, 4, and that is why it is our solution. It is the point where the two lines meet. It's the only point that they have in common. A solution is the point in common for both of these equations. All right, so now that we understand kind of what the solution means, let's take a look at a couple more ways to get there. We're going to graph these problems, and we're going to get our answer by showing, well, what happens. So let's go ahead and graph the first one. I'll give you guys a second right here. Actually, I'm going to give you 3 minutes. See if you can graph this. All right, so let's go ahead and graph these and see what they look like. When we look at this first one, we have it solved for y. I'm going to graph this one in blue and the other one in red. So we start with -8. We're going to go a positive slope of 2. That's going up here. And it's going to look something like this. Not perfect, but we get the idea. The other one is going to come right here, and you're going to start at -2, and that's a slope of -1/1. I can see by my dots, the dots are a little bit easier way to find the actual point of intersection if it's a whole number. And so this point right here is going to be 2, -4. That's the solution. Now, let's take a look at the second one and see what we recognize about it. There's something a little bit different. Did you guys notice it? The slopes are exactly the same. They're both 3/2. Let's see what happens because this is up 3/2, up 3/2, and down 3, back 2, down 3, back 2. This is one line, and the other line is going to have that exact same slope. It goes through -1, up 3/2, up 3/2. We realize pretty quickly that slope puts them in the same direction, and they are never going to meet. Never going to meet. We have a name for that. Those are parallel. So there is no solution to this. The last one over here, we take a look at it also. We realize when we graph the blue one is -2 and down 1/2, down 1/2, back 1, up 2, or back 2, up 1, back 2, up 1. And this is our line. When we graph the red one, it is going to be exactly the same thing. That means that every point that these two have in common is every point on the graph. So that means they're going to have infinitely many points in common. And those are the three types of solutions. The last two are kind of weird. They are a little bit different. The second one, parallel, has the same slope but different y-intercepts. That's going to have no solution. And then the last one is actually called coinciding lines. And those coinciding lines means that every point on the line is going to be a solution. Now, it's not that every point is a solution, because this point right here, that's not a solution, but every point on the line is a solution, so that makes it infinite. All right, let's take a look at a problem right here and solve this system of equations. All right, let's see. That was, oh yeah, the exact same one that we had right there. We solved it by graphing. Let's go ahead and solve it by substitution. I'm going to take this right here that is 3x, or 3 over 2x minus 1, and plug it in for the other one. So then I'm going to be writing this as 3 over 2x minus 1 is equal to 3 over 2x plus 5. So when we go to solve this and we subtract 3 over 2x on both sides, it cancels out the x. And check out what happens. We're left with a statement that is negative 1 is equal to 5. This statement is just not true. It is a false statement. All right? And so that means there's going to be no solution. Now, if you remember the drawing up above, that meant they were parallel. So if you have an equation that solves out and the variables all go away and you have a non-true or false answer, then it's going to be no solution. Let's take a look at the other one that we had right up here, which was infinitely many solutions. And if we do that, we have, I'm going to put them together, negative 1/2 x minus 2 is equal to negative 1/2 x minus 2. You can kind of see what's coming here, because if I add 1/2 x to both sides, it cancels out the x's, and we're left with negative 2 equals negative 2. Now the difference between this and the last one is this one's true. And that means that's going to have infinitely many solutions. They're the same line. Okay? So now we can identify we can identify those special cases of no solutions and infinitely many solutions by recognizing them when we solve the equation and we get an answer that gets rid of all the x's or all the y's. All right, let's take a look at the story problem. So this is a story problem right here. And in story problems, we're going to need to represent something with a variable. All right, so let's see if we can figure out what variables we might need to create for this particular problem. Bharat and Ingrid leave their building at the same time on bikes and travel in opposite directions. If Bharat's speed is 12 kilometers per hour and Ingrid's speed is 14 kilometers per hour, how long will it take until they are 78 kilometers apart? We need to figure out what we don't know, and we can write as a variable and figure out. So let's take a look at the last question. It says, how long will they take until they are this far apart? Well, that's one thing we don't know. We don't know time. So I'm going to say let t equal time. And that's going to be in hours. So I can take that right here. And anytime I have that time that they took on the ride, I'm going to replace it with t. Now the other thing that we have right here, it says b for distance. Now it says Bharat rides a distance of b kilometers. Write an expression to represent how far Ingrid rides. Well, let's say that this was 30. If I knew Bharat was driving 30 kilometers or riding 30 kilometers, what would be left for Ingrid? Well, it'd be the rest of the 78. So what I'm going to do is I'm going to write a variable and say let b equal the distance brought goes, and I'm going to write Ingrid. The distance Ingrid goes is whatever 78 minus Barat's distance is. So even though we haven't created a third variable for it, we can actually represent how far Ingrid goes by saying it's got to be 78 minus b. What we're going to do is write an equation. And a nice way that we can do this is we can write an equation for Ingrid, and we can write an equation for Barat. So Ingrid's equation is going to have her distance, 78 minus b, is equal to, then, let's see, 78 minus b is going to be our distance. And let's see, that was 14 miles an hour, or 14 kilometers an hour, times the number of hours she went. Cool, there's our equation. And then we have Barat, and Barat went a distance of b, if you remember up here. And Barat is going 12 kilometers per hour times t, the number of hours that we've taken. And so what we're going to do right here is I have one of them that's already solved. I have b, and so I'm going to take that b, I'm going to plug it in. So we have, instead of b in this equation, 12t. Now I'm going to put the other things around it. I'm going to say, okay, 78 minus 12t is equal to 14t. Now let's combine some things. I'm going to take the 78, bring the 12 over to the other side and get 26, and then divide by 26 and get the time is equal to 3. Now, it might be not what I'm looking for. I want to find how far Barat and Ingrid, or the distance also. So this was actually the question that they asked right here. It says, how long will it take until they're that far apart? It's going to take 3 hours. But we could also plug in and find out exactly how far Barat went in that 3 hours, which is going to be 12 times 3, or 36, in this case, kilometers. All right, there's our last problem. And what I'd like you guys to do, or you all to do, is delta math number 5. So delta math number 5 is written and goes along with doing a lot of those solving systems of equations, graphing things, doing some solving by graphing, and a couple story problems too. So that's what I want you to work on right now. Good luck, and I will see you on Tuesday. Take care, y'all.